This is 2020 paper 2, question 7. So here we have a vertical mobile phone mast DC of a height h is secured with two cables A and C of length x meters and BC of length y meters as shown in the diagram. So the angle of elevation at the top of the mast from A is 30 degrees and from B is 45 degrees. So explain why BCA is 105. So BCA is this angle here. So if we find the angles here, so here we have 180 minus the 90 minus the 30, and that gives us 60. That's for this angle here. And then if we do 180 minus 90 minus 45, that gives us 45, which gives us this angle here. And when we add them together, we get 105. So that's 10 marks, and the reason here is also you could have found, yeah, that's it. So that's part 1. Part 2 then, the horizontal distance from A to B, so you're trying to find the distance from here to here, is 100 meters. Use the triangle ABC to find the length of y. So you're trying to find the length of here. Give your answer correct to one decimal place. So we're going to use the sine rule because it's a non-right angle triangle. You can use the sine rule or the cosine rule. If you have this side here, you need to have the known angle opposite it, which you do. And if you're looking for a y, you need to have the known angle opposite that, which you also do. So A over sine A is equal to B over sine B is equal to C over sine C. And just remember that you just use 2 at a time. So we're looking for y, so that's going to go over sin 30, because that's opposite it. And then we have our 100 meters from A to B, and you put that over the sin of 105 degrees. And then you just cross multiply. So that means that y is equal to 100 by sin 30 over the sin 105. And then put that into your calculator, correct to one decimal place is 51.8 meters. And that is 10 marks. For part 3 then, use your answer from part 3 here. Part 2 to otherwise find the value of h and the value of x, give your answer correct to one decimal place. So we're trying to find the height here. So we can use the 51.8, which we said was here, which is now y. So to find the height of the mast, if we do just sin, cos and tan. So this is your angle here, this is the opposite, and then this is the hypotenuse. So you can either use so, ca, or toa. So because you have the opposite and the hypotenuse, you're going to use sin. So you're going to say the sin of the angle, which is 45 degrees, is equal to the opposite, which is x, or the h, what you're looking for, over the hypotenuse, which is 51.8, and then just cross multiply. So x is equal to 51.8 multiplied by the sin 45. So x here is equal to 36.6 meters to the nearest one decimal place. Then to find the length of the cable x, well, if you know that that's 36.6, again you can use sin, cos or tan. So if we label opposite here again, and the hypotenuse, we're going to use sin again. So sin of 30 degrees is equal to the opposite, which is 36.6 from the previous question, over x, and then you cross multiply. So x is equal to 36.6 over the sin of 30 degrees. So x is equal to 73.2 meters. So 10 marks for both of those. For part B then, so the two cables to secure the mast cost €25 per metre. The mast itself costs €580 per metre. So VAT at 23% is then added in each case. Calculate the total cost of the cables and mast after VAT is included. So we know that the cable is €25 per metre. So we're going to have to add the 73.2 and the 51.8 together. And then we have to charge the 580 for the mast, and the mast is 36.6 meters high. So if we multiply that together, so 25 multiplied together by, so if I add 73.2 plus 51.8 together, that gives me 125. So if I do 25 times 125, that's 3,125. And then if I add 580 multiplied by 36.6, that's 21,228. And if I just add them together, that gives us 24,353. And then I just have to multiply it by 23%. You get 5,601.19, and then add that on. So if I add that on, I get 29,954.19. Okay, so that's 10 marks. So that's how much it's going to cost them all together. So here for part C, you've got the mast can provide a strong signal for an area in the shape of a regular hexagon of side 8 kilometers as shown in the diagram. So find the area of the hexagon shown. So give your answer in kilometers squared to the nearest two decimal places. So to find the area of the triangle, it's half AB sine C. So you're going to find the area of one triangle and then multiply it by 6, and that'll give you the area of the hexagon. So that's a half times 8 times 8 times sin 60, and you're getting the 60 from this 360 degrees in a circle divided by 6, so that's 60. And then we just want to multiply the area of the triangle by 6 because there's 6 of them, and you get 166.28 kilometers squared to two decimal places. Part 2 then, so the circle which touches all vertices of the hexagon can show areas where the signal is weak. So one of the areas is shaded in the diagram. Find the area of the shaded part. So if you find the area of the circle, so that's pi times 8 squared. And then if you take away the area of the hexagon, which is 166.28, that'll give you 34.78. That'll give you the area of the shaded parts all around the hexagon between the circle. And then if you just divide that by 6 then, that gives you the area of one of those shaded parts. So 5.7969, and then rounded to one decimal place, that's just 5.8 kilometers squared.